Hello students. So today we start new topic is Kirchhoff rule, and that's very important. Okay. So Kirchhoff rule. Rules or law? Okay. Some books say that's the Kirchhoff's rule. Some books say the Kirchhoff's law. They're both the same. So Kirchhoff's rules are there are the two categories. One is a node rule or node law, or called junction rule or junction law. Okay, the node rule or junction rule, or someone say that is, some books say that is a point rule, and other is a branch or loop rule or loop law. So, and these are the node rule or node law applies on current. Kirchhoff current law and Kirchhoff's voltage law. Okay, so that's very important. That is a voltage law and that is a current law. So what is Kirchhoff's current law? KCL. And these laws, another name is a node rule or junction rule or a point rule. So at a point or junction, okay, all algebraic sum of current component sum of current component becomes 0. And you say that that's a node, a point or a junction, and there is a one current, another. Okay, these current I1 enter that node. Suppose node is point P node, and here that I2 leave from point P, and I3 leave and I4 enter. Here the algebraic sum say that is either towards point or leave the point. Okay, suppose you say that towards point P, get a plus sign, or away from P, get minus sign. Okay, so here you see that I1 current is towards P, so towards P is a plus, so plus I1, and I2 is away from P, that's the minus I2, I3 away, that's the minus, and I4 towards, that's a plus. 0. Okay, so that's my choice. If you want to choose a towards plus P is a minus and away from P, that's a plus, now you get the same answer. Okay, so see that, now flip that, it's towards plus and away towards the minus, sorry, and away plus. Now see that I1 towards minus I1, away I2 away. Okay, away is here the plus I2, and I3 away plus I3, and I4 towards the minus, I4 is 0. Now minus common, so here I1 minus I2 minus I3 plus I4 equal to 0. So now if I convert minus left to right side, so get I1 minus I2 minus I3 plus I4 equal to 0. That's the same equation here. These equation are the same equation. So towards or away, if you choose a toward plus or away minus or towards minus away plus, that is your user defined. Okay, that's not a basic rule. The basic common is that at a point or a junction, all algebraic sum of current component, becomes 0. So the KCL, Kirchhoff's current law, and Kirchhoff's voltage law, or that is as a loop law. So what is the loop law? KVL. The KVL states that algebraic sum of all potential in a closed loop becomes 0. Here is becomes 0 current, and here with the potential voltage, Kirchhoff's voltage law or voltage rule. So now a closed loop, that's a very important. Here there is a closed loop. Okay, that's a very important. What is a closed loop? Suppose a basic consideration, a basic circuit. There is a source, voltage source. Okay, suppose that is a V, and there is a resistance R1, R2. Here is another resistance R3. There is 3 resistance, and you see that the current direction, the very important current direction, these are the plus, that is a minus. Current goes plus to minus direction, so there is the I in that direction. And R1, R2 and R3 all connected in series, so that's why the current value be the same. I and I be the same. Okay, now apply KVL here. Apply KVL here. Now suppose here they apply KCL at point P. Here KCL at point P. Okay, and here that KVL at loop. Suppose say the L1 loop. Okay, now you choose on any arbitrary direction, either clockwise direction or anti-clockwise direction. Now you choose, suppose first is the clockwise direction. You choose the blue color line is a clockwise direction. Okay, now check that the satisfying current direction with this clock direction, I choose that direction. If both be the same, so be the plus. Otherwise, if I both in opposite direction, these direction and these direction opposite, so become a minus, or vice versa. If you choose that's the same direction with the minus or opposite direction with the plus, and you get the same answer. So here B from starting here, so minus to plus, but current direction plus to minus. So that's why the minus B, and here resistance has no polarity, so that's the current direction in that direction, and these current direction and these direction be the same, so that is a plus. So I choose the same direction with a plus, choose same direction plus opposite minus. So I R1, and you see that these R2 current passes to R2, that direction the same, so that is plus I R2, and similarly that current direction the same, plus I R3 0. Okay, that's the equation, KVL equation. Okay, and that is depending on if you choose the same direction with the minus or opposite direction with the plus, or you choose the anti-clockwise direction, both are satisfied. The basic rule is the algebraic sum of all potential drop. Here the potential drop of R1, that is IR1, potential drop across R2 is the IR2, potential drop across R3 is the IR3. Okay, so that's be the closed loop 0. Suppose you say that is a potential drop IR1, that is called V1, that drop is called V1, that drop is V2, the drop is V3. Okay. And the algebraic sum here, these are added, so we know the from Ohm's law V equal to IR, so that's the reason. Okay. Now the very important, all the concept here. Okay. Now, clear the KCL and KVL. Okay, that's a very two important law. Okay, very important in board exam or JEE and Neet exam. Now take a solve some basic uh, numerical. Okay, some take an example. So apply how to apply KCL KVL. Important is very important. How to apply KCL and KVL in a circuit. Okay, apply. Choose a circuit here. Suppose there is a circuit. Okay, there is a circuit. Suppose basic circuit here. Suppose there is two source. Basic simple circuit. Okay, suppose that is a V1, that's a V2, and here you put another resistance R1, R2 and R3. Okay, now here you see that how to apply KCL and KVL. The very important is that the potential source, voltage source here, the battery, that is V1 means here plus, that's a minus. So current flows through in that direction. If I say that is a I1, and here from V2, that's also source, and current from these drawing to I2. Now that's a node. Here that is a single node. Now here single node or different side, the current value will be the same. Okay, there is not a junction point. That's the junction point. That's a junction point. Because the three branches are connected here. So that's a these point are junction point. These two points are not a junction point. These point are also a junction point. Here we apply KCL at this point. Apply KCL here. And we don't know the current direction, but current passes through the R2. So that's X unknown. Okay. So current passes through in that direction. This is the I1 from V1, I2 from V2. So you see that the basic concept towards junction, the basic concept of KCL, applying KCL. So towards the junction, current flow towards the junction with a plus, towards junction plus, away minus. So here the towards the junction, I1 with a plus, I2 with a plus, and away with a minus. So I1 plus I2 minus X, because X is the away from the junction point, that is equal to 0. So I1 plus I2 you get that is equal to X. So value of X is I1 plus I2. The current passes to the R2 resistor is I1 plus I2. Now we know that how to apply the KCL. That's very easy. Okay. Here that I1 plus I2. Okay. And that is I2. And if you see that carefully, these are the series line. These are the series. There is no junction here. That's why in series, current value will not change. You know that. So that's why I2 passes from this direction. Now if you apply apply KCL at blue color junction, because there are three bunch here, and you know that enter from the towards the junction, that is I1 plus I2, and leave the junction is I2, and I check that our assumption is right or wrong in that case. Suppose that is a y unknown and check that y value. Okay. So if R1 enter, sorry, I1 plus I2 enter and I2 leaves. So towards the junction with the plus. So towards junction with the plus. So here I1 plus I2. So towards the junction plus I1 plus I2 and leave the junction with a minus I2, and there is a y also leave the junction minus y equal to 0. So cancel these two. So I1 equal to y. So our assumption will be right. Okay, because this line is a series line. The current value will be the same here. Okay, so that's the I1. So y equal to I1. Suppose, let's say that if you take an assumption y in, suppose in that direction. Suppose you take a y in that direction. Okay, so the assumption y in that direction. Let's say y in that direction. Now apply junction rule by KCL here at that junction. So similar concept towards the junction with a plus. So I1 plus I2 and leave the junction with a minus I2 here, and y also towards the junction with a plus 1. Okay, so there's a cancel. So y equal to minus I1. So our assumption is that the current direction here in that direction, but minus I1. Okay, but if I change actual direction is a opposite direction, that's a minus here. So opposite direction will obviously plus. So our assumption is y equal to minus I1. That direction in that left to right. But here original direction is a right to left. So right to left is a plus, left to right is a minus. So there is flip that 180 degree opposite. So that become a right. Okay. Our assumption is in that direction is a minus, the opposite direction with a plus. Clear? If you choose any direction, always satisfy the correct. If you know the concept and know the how to apply KCL, always you get a correct result. Okay. Now here we apply KVL. Very important. How to apply KVL here. So you see that there is a two closed loop. One loop 1 that is a loop 2. There is a two closed loop, loop 1 and loop 2. So here we apply KVL in closed loop. Now we apply KVL. So copy the diagram first. Okay, so erase some excess first. Know the value of x. Okay, now applying KVL in loop 1. Okay, now choose any arbitrary current direction, either clockwise or anti-clockwise. Previous we apply it here the clockwise. Okay, now we apply anti-clockwise. So in that yellow. Okay, now check our assumption and current direction be the same or different. Check that. So applying loop 1. So starting from here, so potential drop of all closed loop, algebraic sum of all closed loop, potential drop across the closed loop becomes 0. Algebraic sum of potential. Okay. So potential drop across R1 is a IR1, but our direction be that right to left, but original current direction is left to right. So that is the opposite direction. Okay, that do not satisfy our direction. So that's a minus. Minus I1 R1. Here plus to minus, and you know that from current flow in a cell, that is a plus to minus direction, and our direction will be the same. So plus V1. Here is no resistance, no potential drop here. Now here R2, and R2 current direction is downward and our direction is upward. So opposite direction, that's a minus. Minus potential drop across R2. Potential drop across R2 is the IR from Ohm's law. So I here I1 plus I2, and that is times R2. There is no potential drop or no load here. That is equal to algebraic sum becomes 0. That's the equation number 1. Now apply KVL in loop 2. Same, now apply clockwise here. Clockwise. From starting from here. So I2 and R3 potential drop across R3. So there is an opposite direction. Our direction is this. Choose. But I2 in right to left. So our direction is left to right. So that is the minus. Minus potential drop, that is I2 R3 in loop 2. KVL apply in loop 2. Okay. Now that is plus to minus, same. Plus to minus. So plus V2. No potential drop here. So R2 here. These direction and original current direction via R2 be the opposite. That's a minus. Minus I1 plus I2. Okay. Minus 2 times, that is also equal to 0. That's the equation number 2. Okay, clear? Now we get two equations, and I1 and I2, the two unknown, and you can solve easily. Okay, very easy numerical, and solve this via very easy way. Okay, so basic important is that applying KCL, KVL, okay, in any direction, if any loop, you can apply here, either clockwise or anti-clockwise. Okay, clear how to apply KCL, KVL, and if you apply practice more, then solving this very easy. And if you get a two equation, then a quadratic solution of two quadratic equation, two linear equation solution, either elimination method or cross multiplication method or substitution method, there whatever formula you want to apply, and you apply that, then you get a correct result. Okay, now take another example, very important. Another example, here is an example. Suppose there is a source, there is another source, there is another. No. Okay, now here I apply KCL. I try to apply KCL and KVL. Okay, here you see the junction point. There is a one junction point, a junction point. Here is a junction point, junction point. First find all junction points and potential. Suppose that is V1, V2, suppose V3 and V4. Okay. Now very important, the current direction is very important. Suppose starting from here, in that direction current. Okay. Now suppose here in that direction, here, and you see that here, now this direction here, now at that direction here. So at the junction point, here, put that here in that direction. Okay. Now with the current is a I. Suppose there is a current I. So there is a four junction. So junction 1, junction 2, junction 3, junction 4, and junction 5. 5 junction. So current in that direction is I. Okay, and suppose that is from here, that is I1, and here from KCL apply that J1 junction, I1 enter the junction and I enter the junction and I1 also enter the junction. Suppose you say that is I1, then say the easiest way, that is I2. I1 enter the junction and I2 enter the junction. And here the current direction is away from the junction. If towards the junction be the plus, away is the minus, so that is the x unknown. So I1 plus I2 minus x equal to 0. So I1 plus I2 equal to x. So that is I1 plus I2. Now here is that x. Okay. So similar, there is a series. So no junction point here. That is similar. I1 plus I2 here. Okay. I1 plus I2 here. Similar. So suppose there is a I4. So I1, I2 towards the junction 4. I4 also towards the junction 4. Suppose that is a y. That is a plus minus y. Similar concept here. So you get I1 plus I2 plus I4. Suppose there is a I3 from here. Okay, I3. So I2 leave the junction. From J to I2 leave the junction. So I3 enter the junction. Okay, so we now calculate that Z value. What is the current value of this branch? So towards the junction with a plus. So here from J in J2 KCL, I1 enter I1 plus I2 plus I4 from this branch, and obviously plus I3, I2 leave, minus I2 leave, and Z also leave, minus Z equal to 0. So I2 cancel. So Z equal to I1, I4, I3. You get I1 plus I3 plus I4. Now erase Z. I1, I3, I4. That is Z in right side to get I1, I3, I4. Okay. Now here from junction 3. Okay. And you see that I1 leave the junction. Suppose that is called M. Now calculate the current is this branch M. I1 leave the junction. A series, no junction point, so I1 leave the junction. So enter the junction is J3. Enter the junction is plus. So I1 plus I3 plus I4, and I1 leave, minus I1 plus minus m obviously leave, that is equal to 0. So I1 cancel, I3 plus I4. Okay, so m equal to I3 plus I4. Yes, that we get m equal to I3 plus I4. Similar here, that is no branch here, no junction point here. That's the I3 plus I4. Now the junction 5. That is I3, I4 towards the junction plus. Okay, and I3 leave the junction, that is a minus. Suppose these are the n, unknown n. Minus n leave the junction. I3 cancel. So n equal to I4. So here's the n and put I4. And you see that these here is a no junction point. There is a series, okay, a line. That is the I4 and that is the I4. So our assumption, our current KCL, the same apply here. It is I4 and I4 satisfied. Okay, our applying KCL being satisfied. Okay, the need a practice. If you practice more and now you can apply them easily. Okay, there's a basic mathematics. Okay, and if you have NCERT, Newton's, or any other book, but there is a too much huge practice. If you're doing huge number of practice, there is a very easy to apply KCL KVL, and you see that there is a satisfied all that here we same. Okay, so today end the class here, and next class there is a 2 or 3 example how to apply KVL. Okay, so today in the class here, if any doubt put in comment section, I will try to give the answer. So today in the class here, thank you.